Imagine sailing into the unknown. No compass, no GPS, no satellite images to guide your way. Just you, your ship, and an endless expanse of cold, gray water stretching in every direction. The horizon offers no comfort, no landmarks, nothing but the thin line where sea meets sky. Now imagine doing this not for a day, but for weeks, crossing oceans, finding lands no one in your world has ever seen, and somehow, against all odds, finding your way back home. This wasn't fantasy. This was the Viking Age, and the men who did this weren't lucky. They were masters of secrets that modern science is only now beginning to understand. For centuries, historians dismissed Viking navigation as primitive guesswork, lucky breaks guided by courage and little else. But the truth is far more extraordinary. The Vikings didn't conquer the seas because they were fearless. They conquered them because they were brilliant. They developed a sophisticated understanding of nature that turned the ocean into a readable map, the sky into a compass, and the behavior of birds and waves into a language only they could speak. These weren't just warriors with boats. They were scientists before science had a name, astronomers without telescopes, and navigators who could find Iceland in a storm when modern sailors would be utterly lost. The story begins not with technology, but with observation. While other cultures relied on staying close to shore, the Vikings had no choice but to venture into open water. Scandinavia's jagged coastline and scattered islands demanded it. But turning necessity into mastery required something more than bravery. It required a different way of seeing the world. Where others saw chaos in the ocean, Vikings saw patterns. Where others saw only clouds and water, they saw signs and signals. The secret wasn't in what they had. It was in what they knew how to read. Let's start with the sun. In the northern latitudes where Vikings lived, the sun never climbs as high as it does near the equator, but it traces a predictable arc across the sky. The Vikings understood this arc intimately. At noon, when the sun reached its highest point, it always pointed south. This wasn't abstract knowledge. It was survival. A Viking navigator would use a simple wooden disc called a bearing dial, marked with notches representing different directions. By holding a pin or gnomon in the center and watching where its shadow fell at noon, they could establish south, and from there, every other direction. It sounds simple, but the precision required was remarkable. A few degrees off could mean missing Iceland entirely and sailing into oblivion. But here's where it gets more interesting. The sun was reliable in clear weather, but the North Atlantic isn't known for clear weather. Fog, storms, and overcast skies could hide the sun for days. This is where the legendary Sunstone enters the story. For decades, the Sunstone was considered mythology, a magical crystal mentioned in old sagas but dismissed as Viking fantasy. Then scientists made a discovery that changed everything. Certain crystals, particularly Icelandic spar, a form of calcite, have a property called birefringence. When you look through them at the sky, even when the sun is hidden behind clouds, they create patterns of light that reveal the sun's position. By rotating the crystal and watching for specific polarization patterns, a navigator could locate the sun with startling accuracy, even in thick fog. In 2013, researchers tested this theory by examining a damaged calcite crystal found in an Elizabethan shipwreck, centuries after the Viking Age. Using computer simulations, they demonstrated that even under heavy cloud cover, a navigator with a sunstone could determine the sun's position to within a few degrees. If this technology existed in the 16th century, it almost certainly existed in the Viking Age. The sagas weren't fairy tales. They were instruction manuals, but the sun and stones alone couldn't guide you across 1,000 miles of ocean. You needed to know where you were going and how to stay on course. This is where Viking knowledge became truly sophisticated. They didn't think of navigation as moving toward a point on a map. They thought of it as staying on a line of latitude. If you knew Iceland was at a certain latitude, and you knew how to maintain that latitude, you could sail east or west until you hit land. It's called latitude sailing, and it requires an almost supernatural awareness of your position relative to the sun and stars. The North Star, Polaris, was their anchor in the night sky. Unlike other stars that wheel across the heavens, Polaris remains fixed, always pointing north. By measuring its height above the horizon, a Viking could determine how far north or south they were. They used their hands, their fists, the width of fingers held at arm's length, calibrating these measurements against known locations. A navigator who knew that Polaris sat exactly 3 fists above the horizon at home could sail west until he'd crossed the ocean, then adjust north or south until Polaris returned to that same height. When it did, he'd know he was at the right latitude. Then it was just a matter of sailing east or west until land appeared. But what about during summer, when the northern nights are so short that stars barely have time to appear, or during the perpetual daylight of the far north? The Vikings adapted. They watched the sun's midnight position, noting how it skimmed along the northern horizon without fully setting. They understood that the sun's lowest point shifted depending on latitude. Combined with daytime observations, they could maintain their course through endless twilight. Then there's the ocean itself, which the Vikings learned to read like a manuscript. Swells, the long rolling waves generated by distant storms, travel in consistent directions and can be felt even when you can't see beyond your bow. A skilled helmsman could keep his ship oriented by the feel of these swells beneath his feet. Maintaining course, even in fog or darkness, is a kind of navigation that can't be taught from books. It requires years of experience, a physical intimacy with the sea's rhythms, the ability to sense direction through your body rather than your eyes. Birds were another secret. Vikings knew that certain seabirds, like puffins and guillemots, never venture more than a certain distance from land. If you saw them in the evening flying in a particular direction, you knew land was that way, and you knew roughly how far. The sagas tell of Vikings carrying ravens on their ships. When they suspected land was near but couldn't see it, they'd release a raven. If the bird flew in circles and returned to the ship, there was no land nearby. If it flew off in a straight line and didn't return, the Vikings would follow its course. Ravens, being land birds, possessed an instinct for finding shore that no human tool could match. Even the water told stories. In the North Atlantic, currents flow in predictable patterns. The warm Gulf Stream moves northeast from the Americas toward Europe. Cold water flows south from the Arctic. Where these currents meet, the water changes color, temperature, and behavior. Experienced navigators could detect these boundaries, using them as invisible highways across the ocean. They'd sample the water temperature with their hands, note subtle color shifts from deep blue to greenish gray, feel changes in the waves. Each variation was a signpost. The Vikings also understood something that modern sailors often forget. The sea has a smell. Approaching land, the scent of vegetation, earth, and even smoke from distant fires could be detected miles offshore, especially with a favorable wind. Pack ice has a distinctive smell. Shallow water over sand smells different than deep water. These aren't mystical abilities. They're the result of paying attention, of treating the ocean not as an obstacle, but as a living thing that speaks to those who know how to listen. Perhaps most impressive was their dead reckoning, the art of tracking your position by calculating speed and direction over time. Viking navigators would estimate their ship's speed by watching foam and debris pass the hull, by the feel of the wind, by the sound of water rushing along the strakes. They'd note course changes, estimate distances traveled, and maintain a mental map of where they were relative to where they'd been. This required intense concentration and an almost mathematical mind, constantly updating calculations based on changing conditions. Over a voyage of weeks, the margin for error was razor thin, yet somehow they made it work. All of these techniques, sundials and sunstones, star positions and bird flight, swells and currents, and dead reckoning, weren't used in isolation. They were woven together into a comprehensive system, each method checking and confirming the others. If your latitude by the North Star didn't match your latitude by the noon sun, you knew something was wrong. If the birds suggested land to the west, but the swells indicated you'd drifted south, you'd adjust. Navigation became a constant conversation between sailor and sea, each observation adding another piece to the puzzle. What makes this even more remarkable is that all of this knowledge was transmitted orally. Vikings didn't have navigation schools or textbooks. Boys learned by watching their fathers, by making voyages, by absorbing techniques through experience rather than instruction. The best navigators were revered, their knowledge treated as precious as gold. In a culture built on exploration and trade, the man who could find his way across the ocean and back was the man who made everything else possible. Settlements, raids, trade routes, the entire Viking expansion depended on these navigators and the secrets they carried in their minds. And here's what's truly haunting. Much of this knowledge was lost. When the Viking Age ended, when Christianity brought written records, but also cultural change, when navigation instruments like the magnetic compass arrived from other parts of the world, the old ways faded. By the time scholars thought to document Viking navigation techniques, most of the practitioners were gone. What we know now comes from fragments and sagas, from archaeological finds, from testing theories against what we know about astronomy and oceanography. We're rediscovering their secrets piece by piece, often with astonishment at how sophisticated their methods were. Modern science has vindicated the Vikings. Experiments with replica ships using only Viking Age techniques have successfully crossed the Atlantic. Researchers have confirmed the sunstones' effectiveness, validated latitude sailing methods, demonstrated that experienced sailors can indeed navigate by swell patterns and watercolor. What once seemed like mythology or luck is now recognized as systematic, scientific knowledge. The Vikings weren't primitive. In some ways, they understood their environment more deeply than we understand ours. They had to. Their survival depended on it. So the next time you use GPS to find a coffee shop 3 blocks away, think about those Viking navigators standing on a wooden deck in the middle of the North Atlantic. No land in sight, storms brewing, and yet somehow knowing exactly where they were and where they needed to go. They couldn't punch coordinates into a device. They had to become part of the ocean itself, reading it like a language, trusting observations and instincts honed over generations. They sailed to Iceland, to Greenland, to North America, 500 years before Columbus, not because they had better tools, but because they had better knowledge. That's the real secret. It wasn't about having the right equipment. It was about having the right eyes, the patience to observe, the wisdom to recognize patterns, and the courage to trust what you'd learned when everything around you was gray water and uncertainty. The Vikings conquered the seas not despite their lack of compasses, but because they never needed them. They had something better. They had understanding, and in the end, that's always been the most powerful navigation tool of all.